Welcome back to this NPTEL online certification course in molecular rearrangement and reactive intermediates. So last couple of classes we have learned about carbon ion. Mostly we talk about the organolithium reagent. We talk about the generation of organolithium using the metal halogen exchange, the transmetalation reaction in the last class, and in the today's class I am going to show you some of the reactions of the organolithium reagents. So I am going to talk about the nucleophilic addition. So there could be a 1,2 versus 1,4 addition. Then the reaction with the epoxide, aldehydes, and then you can see about the stereoselectivity of these reactions, and of course I am going to talk about the reaction with cyanide and others. Okay, and then at the end I am going to talk about a couple of problems. So first thing is we are going to talk about the if you have organolithium and if you are if you have a enone system here, then the question comes, it is going to go for a 1,2 addition or it is going to, so we are talking about 1,2 means if you give them like let us see 1, 2, 3, 4. So now we are talking about it will be a 1,2 means you are adding here, the nucleophile can come and add here to give this product, or it can go for a 1,4, that means the nucleophile is attacking or the RLI going to attack from this side to form this product. Okay. So what is happening, most highly reactive organolithium favors the 1,2 addition. That means if you see once the organolithium is very reactive like the methyl lithium, butyl lithium, all if you add here, it is going to go for this 1,2 addition as a major. Okay, but once you have some sort of a stabilization, if you use some sort of a stabilizing group here with the organolithiums, which are where you have to use a HMPA. As I mentioned about HMPA in the previous classes, what you have learned that HMPA can also able to coordinate with the lithium. Okay. So now what is going to happen, the HMPA can coordinate with the lithium, that can make the lithium go for some sort of a, so you can see here if you have a THF, that is the 1,2 addition is the major. Once you add HMPA, then we will see that the addition happening 95% here. Again this is depend on whatever lithium also using, you have to also think about the lithium you are choosing for this type of reactions. The lithium which was used in this particular addition is kind of a stabilized lithium. So if you have a non-stabilized lithium, it will mostly go, despite the condition, go for 1,2 addition. Once you have a stabilized lithium and once you use a HMPA which can stabilize the lithium even more, then you found out that it can go for a 1,4 addition. I am going to come back with some example in a minute. So you can see here in this particular cases, if I am using a phenyl lithium without any type of additives here, again as I said, the phenyl lithium is a reactive one, it is going to act to the heart center here. So the organolithiums are a hard nucleophile, so mostly you will end up seeing a 1,2 addition product to get to the corresponding alcohol after treating with the water. Again if it is a here if you have a hindrance, so there is another important things here, that if you have this carbonyl group here, so which is not getting a place to attack because the nucleophile cannot approach here because of the steric factor. In that case what is going to happen, then in that case you will see the using organolithium also you will only see the 1,4 addition going to take place. So the lithium can coordinate with the oxygen to make it more electrophilic, and now there will be 1,4 addition going to take place here to get to this type of, after you treat with the methanol it is going to get to this corresponding product here. And if you have a epoxide, we know that if you have epoxide, there is a nucleophile can attack to the epoxide to open the epoxide here. So as you see, these are very strong nucleophiles, the RLI that can attack to the epoxide to open and form the corresponding alcohol. Again there is an example here, you can see here there is two different sides the nucleophile can attack. This side is more hindered, so it is going to allow to attack from this side, and as you know, so this is a SN2 reaction happening, so then it is going to happen only from the back side. Correct. So that's how if you treat with the phenyl lithium here, it is going to go for a SN2 reaction, and mostly as I mentioned, the some sort of a phenyl lithium or the other stabilized lithium where you have two stabilizing groups. In that case only you will find out that your reaction is going through some sort of a like SN2 reaction going to be happening. But once if you have a unstabilized lithium like RLI with a alkyl lithiums, then you will see it is it is not a stabilized lithium, and mostly you don't find a SN2 reaction with them. Like if you want to use a alkyl halide also and try to go for a SN2 reactions, then you always have to choose some sort of a stabilized lithium. But of course for epoxide, the nucleophile going to attack here because that is the only place to attack, and after the SN2 it can form the corresponding product. Again here the nucleophile is attacking, so you can see the both side is kind of symmetric. It attack from this side or that side. Only thing, it has to attack from the back side. So this is a SN2 reaction using this corresponding alkyl lithium here to form this corresponding product. As I said, these are very reactive lithium, and there is no other group to be attacked, so epoxide is getting attacked to form the corresponding alcohol. Again here is two things happening here. You can see the the alkyl lithium can also attack to the epoxide. As I said, these are very the reactive nucleophile. Here you have the scenario, it can attack from this side or it can attack from this side, but you can see as it is allylic position, this side is getting attacked to form this corresponding product here. In these cases you are using a BF3 as a Lewis acid which can activate the oxygen. Now the nucleophile can attack from either side, it can attack to get to the corresponding alcohol. In this case also you can see here, in generally if you see the the one side there will be substitution, then the nucleophile prefer to attack from the less hindered side, so that's how it is going to end up this product. If you have a formaldehyde or different aldehyde groups, then there is a 1,2 addition going to take place here, and every cases what is going to happen, depending on the substitution. In formaldehyde there will be primary alcohol. If you have a acetaldehyde, you end up making a secondary alcohol, and if you have a ketones, you end up forming a tertiary alcohol after the protonation. Again, I think it is shown here, the mechanism that of course that the lithiums are very hard nucleophiles, so that's why it is going to attack to the it is going to participate in this 1,2 addition to attacking the carbon here, and then it is taking proton to get to the corresponding alcohols. Okay. So with hindered ketone the stereoselectivity is not high, but preferentially it will attack to give the corresponding HCl alcohol. That means once you have the carbutyl group here in the equatorial position, now what is going to happen, if you use no lithium perchlorate, you still see 65% of this product. That means what is happening, the nucleophile is preferring to attack from this side. But once you use this, the lithium perchlorate, what is happening, the lithium perchlorate is also coordinating with the oxygen. Once it is coordinating with the oxygen here, what is happening, the first side attack, the attacking from this side is also getting hindered because of this, the lithium perchlorate which is coordinating in this position here. So once the Lewis acid is coordinating here, now your nucleophile attack will be majorly happening from this side, from the bottom side to form this product. There is some example, and you might see some of the question in the exam, that if you have aldehyde, you can treat with the organolithium, you can get to the alcohol here. The ketone will give you the corresponding tertiary alcohol. As I said, if you have a benzaldehyde, again it is going to attack. If you have a ketone, it is going to form the corresponding alcohol. Now if you treat with the corresponding deuterium chloride at the end, you have to be careful, or the D2O, you end up getting the OD there, because the lithium will be taking the deuterium from the D2O. If you have a cyanide here, the organolithium attacks here from the imine salt first, it will form the imine and then finally hydrolyze to corresponding carbonyl compound here. Okay. And if you trap with the CO2, I was showing in one of the example in the last class, you end up, what is happening here, the RLI attacks here, okay, to the carbon from the RCO OLI, then it is going to attack one more time, okay, and then finally it is going to take the the proton, and at the end it is going to convert to the corresponding ketone here. So that is going to happen if you again treat with the ester, ester as well, okay, you end up in case of ester also. So here what is happening, you are forming ketone, but if you attack with the ester with this compound, what is going to happen, let's try to write down what is going to happen here. Then the R minus going to attack here. So now you will think that it will end up at the ketone, but that is not the case here. You have extra RLI in the medium, so that will keep on attacking, because now this will be even more, the carbonyl will be more prone to attack with the lithium here, so this can attack again here, and once you get protonated, you will end up generating a corresponding tertiary alcohol. Okay. Again, I think it can, as I mentioned, it can go for this type of carbolithiation. I talked in the last class that if you have organolithium region, it can it can act to the corresponding olefin, go for carbolithiation, and then finally act to another olefin. So you can see we have already talked about this in the, I think, the first lecture, that if you this type of organolithium can also use as a initiator for forming a polymer. So this can constantly adding and form a polymer because of this carbonylation reaction. And of course, if you have waters in the medium or alcohol or amine, if you have some proton in the medium which can be abstracted, then it's the lithium is going to abstract that first to generate the corresponding alkane. Okay. Again, if you have a compounds which have this active, you can see these are the hydrogens which are acidic here. So now you can see these are a very strong base, so they this can able to here there is no group to attack. Now if you use organolithium, they can act as a base here to abstract this proton to generate this corresponding organolithium. Here also if you think about the cyclopentadiene, it's it is going to abstract this proton. This can convert to a aromatic compound here, the corresponding lithium. So these are the acidic proton which is getting abstracted with the lithium region. Again, I think in the previous slide I have mentioned that if you have some acidic proton in the reaction, you are not supposed to use the organolithium, because what is going to happen, instead of the first thing, if you are thinking that the organolithium might going to attack here, but that is not going to happen first. First thing, it is going to abstract this proton. Now if you use excess lithium, of course that is that can come and attack here. But first thing, it is going to go for this abstraction of this acidic proton. If you have alcohol, amides or carboxylic acids, then this proton will be abstracted first. There is an interesting example here. If you have this chloronaphthalene, what is going to happen? The one chloronaphthalene, and if you treat with the phenyl lithium, what you end up seeing? You end up seeing some sort of arylation happening here. Okay. Now if you think about that, okay, we have learned about this SN2 reaction of alkyl lithium the SN2 reaction aryl lithium or some sort of a stabilized lithium we have learned, but you cannot think about that this is going to participate in a SN2 reaction with the vinyl halides. So if I ask you that what type of intermediate this reaction is going to get to the product, you cannot say it is just going for through a SN2 mechanism. Okay, what is happening here? Here something else is happening. I think I already covered in the class. This is going through a benzene or arine intermediate. Okay, so that's how this product is forming here. Because I think if you remember, I have already mentioned that once you have this type of chloride or fluoride in the aromatic ring, then the metal halogen exchange does not happen. Instead of that, it is try to abstract the proton, the orthoproton. Okay, so then what is going to happen? This is going to form this corresponding the negative charge here going to form this corresponding anion, and then it is going to go for elimination to generate this corresponding benzene. So now the phenyl lithium going to attack to the benzene. You can see it can attack through the this position, or it can attack through the other side. That's how it is going to end up making both the products. So now I am going to talk about some of the example. I think we have learned about the generation of organolithium and some of the reaction. Now we are going to go through some of the example here in this particular part. So first thing is we are going to talk about that if you take this particular compound, you can see these are the acidic proton here. So you can see this is a a dithion protection we always use for the protecting of aldehyde group. And if you remember, we use mercury for the deprotection. But in between that, there will be something going to happen. So first thing is, once you take n-butyl lithium, then it is going to abstract this acidic proton to generate the corresponding lithium. And these are the lithium is, as I said, these are the stabilized lithium, because it has two heteroatom next to it. So once you have this stabilized lithium, now it is going to take part, as I said, the stabilized lithium is going to take part in this SN2 type reaction. So it is going to take part SN2 reaction to get to this compound. Now there will be a deep protection, as I said, going to happen to get to the corresponding aldehyde. Again here what is happening, you can see first thing is this, as I said, you have this in the OMe group, and this is a vinyl proton here. So that is going to generate this more stable lithium. As I said, the reacting force of this generation of lithium, that you are generating a more stable lithium. So you starting with n-butyl lithium, you are generating a vinyl lithium here. And now, as I said, it's a vinyl lithium, that means it's a more stable lithium. So what is going to happen? It is going to take part in a SN2 reaction here. And once it is going to take part in SN2 reaction, it is going to form this compound. Now once you treat with the dilute HCl, what is going to happen? It is going to protonate here, and after the hydrolysis, it is going to form this carbonyl compound. As you say, you know, this is a stabilized lithium, it can also react with the corresponding aldehyde. It can attack to the aldehyde, form this alcohol, and now once you use a H3O plus, what is going to happen? It is going to convert to the corresponding carbonyl group. Now you can make this corresponding, you can see here this will be a, in the hydroxy group, you know, going to be in the alpha hydroxy carbonyl compound going to form here. So in the next problem we are going to see that, you know, we started with, you know, this compound here, and now once you treat with the sec-butyl lithium at minus 78 Celsius, what is going to happen here? First that will be A, and now if you treat with the methyl iodide, that will be product B. So we have learned in the reacted lithiation that if you have this reacting group with oxygen, what you have learned, then that can direct the lithium to come here, and now that is going to abstract this proton to generate this corresponding lithium, and that can also form some sort of a stabilization with this Lewis acidic oxygen atom, with this electron deficient oxygen atom, sorry, and then it is going to, now you have this, you know, aryl lithium which is going to trap with methyl iodide to form this corresponding product. Again there is another example. So this, you know, this could be also used as a protecting group. So this, you know, this carbamate can act as a protecting group here. First will be again very similar condition. There will be, you know, formation of this corresponding aryl lithium here, which can, you know, react, which can, this aryl lithium can react with the DMF to form this, you know, to introduce the corresponding aldehyde here. Okay. Again there is another example here. What we have done here, this is very similar to the previous example. First thing is of course the reacted lithiation to generate the lithium here, but now if you suppose you just, you know, warm the reaction to room temperature, if you have not added any electrophile and you have just warmed the reaction to room temperature, then what is going to happen? This lithium is now internally going to get attacked. So this can attack to this carbonyl, so this is going to attack here, form some sort of a 4-member. Okay, now it is going to come back and cleave this bond. So once you know that is happening, you end up, so you at the initially this is a O minus lithium plus. Now this will be at the end, this is going to generate this, and once you take H3O plus, this, you know, OLI going to take proton, become OH, and it will be CONH. Okay, so I think I talk about this anionic phase rearrangement, if you remember. So this is the anionic phase rearrangement here again. So here the question starts that if you have this compound and you treat with N-butyl lithium, what will be compound A first, and then the next thing is if you treat with this epoxide, you know, what will be the compound B. So first thing is, if you see a bromo here and you have N-butyl lithium, you should remember about the metal halogen exchange. Okay, because starting from N-butyl lithium, if you remember the logic of the metal halogen exchange, that we will generate a more stabilized lithium. So using N-butyl lithium, you are generating aryl lithium here. Okay, after the metal halogen exchange, it can add to the epoxide and it will going to attack to the less hindered side of the epoxide. As I mentioned, you know, before that, you know, that's how the reaction is going to happen, and then after it will take the H3O plus, it is going to form this corresponding alcohol. So this will be a product B, and you know this will be a product A. Now the next example you can see here, we didn't talk about in the class, but if you have the instead of carbonyl, you have some sort of imine here. Again, I think the imine can also be acting as a reacting group, correct? So using the tert-butyl lithium, what is happening? You can see this can act as a reacting group. Now these are the protons of the methyl group, which can be abstracted to form this corresponding lithium, and you know this lithium can coordinate, because again the imine nitrogen will be electron rich, okay, which can coordinate this electron deficient, you know, lithium. And now so once it is, you know, treating with the, you know, different type of electrophile, it can you know go for a SN2 attack here to form this product, or it can attack to the aldehyde to get, and then after the treated with the H3O plus, it can go to this product. So that's how you can see, you can now see this will be your A, this will be your B, and finally this will be your C. Again, you know, these are the questions which came in the GATE and JAM and in the previous exam. Another important question here, I think we already talked about that. Once you have this, you know, aryl bromide and you treat with N-butyl lithium, again you can see we are using at minus 100 degrees Celsius. That means why? I think I already told you that if you have a functional group like nitro, then you want to keep them inert. then you have to do the reaction at very low temperatures. So that case you only go for the metal halogen exchange, and you know that this lithium next to the nitro, ortho position of nitro will be stabilized. So that can react with the CO2 to form this corresponding. After it treated with the H3O plus, it is going to form the ortho nitro benzoic acid. Another example here, in this example, you have a cyano group here, you have a bromide here, this aryl bromide, you treating with N-butyl lithium, ether, THF minus 100 degrees Celsius. Again, this is the condition you are using for this metal halogen exchange to generate this corresponding lithium. Once you generate a lithium, it is going to react with the benzophenone here. Okay. After you treat with the H3O plus, it is going to form this corresponding tertiary alcohol. So the A will be your corresponding lithium species, and the B will be this corresponding alcohol. This question is pretty interesting, that you start with this this particular compound where you have a fluorine and the methoxy the 1,2 position versus the in the meta position or the 1,3 position. If you treat the RLi, you get a intermediate A or a compound A, which will treat with the RLi going to give you B, and you treat with CO2 to get to the compound C. So if you see this type of example here, that again I think if you see there is any example where, first thing you should remember that if there is example given which benzene ring having a fluoro or a chloro, and you are treating with a RLi, you should always remember about formation of the benzene, because they cannot go for a metal halogen exchange, so they will go for a deprotonation. Okay, and once it is going to be a deprotonation, it is going to end up forming a benzene. And now the benzene, I think you have learned in the benzene classes that the nucleophile can attack from the meta position or from the ortho position, and we saw that we already told that meta position will be the most favorable attack. It will generate the corresponding lithium, which will be stabilized by the inductive effect of the O-methoxy group, which will now the react with the CO2 to form the corresponding carboxylic acid as a major product. Okay. So that means I think in this type of questions you can write if you have an option of B is given, if your option is B given, then you should choose this option. If it is not given, you can write both the things. You can write this one as well as that one. And once you treat with CO2, you can write this as a major, and that will be your minor product. So in this particular segment, I talk about the different type of question from all these different topic, and then also at the beginning I started talking about if you generate a organolithium and you treat with the aldehyde, what will be your product? If you treat with the epoxide, what will be your product? So we talk about all the different type of reactions. And I think that's all about the organolithium chemistry, and here are the references. In the next classes we are going to talk about the organocopper and the Gigner chemistry. And again thank you so much for coming to the class, and I am going to see you guys in the next class. Thank you.